Hello, grade 12s. Okay, today we're going to do 2.4 compound interest with our TVM solver, and today we're going to add in regular payments. And this is the way a lot of people do investments, where you invest every month. Like it just comes out of your paycheck, your checking account, and it goes into an investment right away, and you don't even have to think about it. It's nice. Okay, so when you invest money, sometimes you may invest a large sum of money and just leave it and not touch it. But other times you invest by making regularly scheduled payments, as in like every month or every 2 weeks or whatever. For example, you get paid monthly for from your job, and you may decide to make monthly deposits of $200 into a savings account where you're investing your money. Just like, this is my savings, I'm going to put it off to the side. We're going to use a TVM solver on our, not our graphing calculators anymore, but on our apps. And instead of saying payment equals 0 like we did yesterday, we're going to use that value right there. All right, so you have decided to invest $250 per month into a bank account. What will your money be worth in 5 years if the interest rate remains unchanged? Okay, let's just go one number at a time and put it into our lineup here. Okay, $250 per month. So I'm making that payment more than once. Like that's not just a oh, sorry, I think it cut out there. So I'm making this payment more than once. It's not just a one-time deal. So I'm not going to put that in present value. I'm actually going to put that in my payment. And it'll be a negative $250, just like yesterday, because it's coming out of my regular checking account. It's coming out of my regular account, and it's going to a special investment account. Okay, interest rate of 6.25, so we'll leave that as a 6.25. Compounded semi-annually, so just go write down semi-annually. Man, I can't spell today, that's a problem. What will your money be worth in 5 years if the interest rate remains unchanged? Okay, I'm missing some stuff. First things first, future value. I want to know that, so I don't know that yet. I'm going to put a little question mark. Payments per year. Now this, yesterday, these two things were the same because we didn't have a payment. Today, it's going to be however often we make this payment. So, $250 per month. So this is monthly. Periods, okay. So it's payments per year, which is 12. Times by 5 years, so that'll be 60 times. So 60 times over the 5 years, we're going to deposit $250. Now, last one here, was there any money in this account before we started? No, so present value is 0. Good time for my app. Let's see here. Got to make sure I have that negative 250. Ooh, don't know what that is. And I forgot to switch to advanced, so great. Let's start over again here. Gotta make sure I'm on advanced because we do need that. We will not be able to do this type of question, actually, this exact type of question, without the advanced. Semi-annually, okay. I think I'm good here. Future value. There we go. Here's my answer. I'm going to write it off to the side where it's really clear that this is my answer. So we put in $250 60 times, and we ended up with this amount of money. There we go. Nice. Now let's just think about how much interest we made. If I put in this much money 60 times, how much money did I invest? We'll just add kind of a question on here. How much did I invest? Let's see. $250 times 60 times. Oh boy, it's a big number. $15,000. And I got $17,000 out of it. So interest equals how much I got out, 17 over $17,000, and subtract what I put in, $2,518.99. That's a lot of money. Like, I'd be happy with an extra $2,000, $2,500. I'd be pretty happy about that. However, I did invest $15,000. Like, that's a lot of money as well. So, it's definitely nice to invest that money and make money off your money, though, right? That's why we invest instead of just holding on to it. Okay, let's try the next one. You'll notice the questions are very similar to yesterday. We're just adding that payment in. Okay, compare the following pair of investments over a 2-year period. In each case, find the future value and state which one's better. Okay, a bank offers an interest rate of 10%, 10, and this is 10 down here as well, actually. 10 and 10, let's move this a little further away. Compounded monthly, so monthly, okay, yeah, just put it down there, okay. First option, now there's actually a typo right here. I want you to cross this off and say end. Did not notice that until just now, actually. Okay, so you could invest $2,400 at the beginning, oh my gosh, at the end of each year. So maybe you're kind of, each paycheck, you take a little bit of money and maybe put it off to the side, not in like a real investment, but maybe just in a checking account or something like that. And you put it off to the side and you think, that's kind of my savings. I'm just going to leave it there for now. We'll see what it grows to. And at the end of the year, you're like, oh, shoot, I have $2,400 extra dollars. Maybe I'll invest this money. So at the end of each year, you're going to invest $2,400. That's going to happen once. So we put it in payment and it will be negative because that will be coming out of our checking account. Present value is 0 because there wasn't anything in there to begin with. Let's see, future value, that's what we want to know. Period per year, or payment per year, we're doing that once, so that is annually. And period, okay, annually is 1 time a year for 2 years. All right, let's see what we get here. Gotta reset and start over. All right, let's see. Okay, future value. So with this plan, I would have invested $4,800 and I would have gotten this amount of money out of it. So I would have made about $250. That's not bad. Like, I'm not mad at that. I'm not mad at that, but I'm not getting rich either. Okay, now let's try a different type of option here. This time we're going to invest $200 at the end of each month. So you'll notice we're actually going to be investing the same amount of money as this one, but we'll see how much interest we get off of it. So this time, each paycheck, you're like, ooh, extra $200, I don't need that, I'm going to invest it right now, instead of waiting until the end of the year. So negative $200, that happens each month, so monthly. Future value, that's what I want to know. Nothing in there to begin with. Period. 12 times a year for 2 years. And let's see. All right. Future value. This time, there we go. This time, investing the same amount of money over 2 years, I ended up with over $200 more. Because this time, I'm investing every month. Every month, I'm earning a little bit of interest on that $200 that I wouldn't have been earning if I had waited until the end of the year to invest. So option B is the better choice. So it's important that when you have a little bit of money, you start to invest as quickly as you can. We do have to be careful. Some investments aren't very liquid, which means that if you needed to get your money back out, you wouldn't be able to. And some of them are very liquid, where you can put money in and take money out as quickly as you'd like. So we do have to be careful about that. Okay. Let's try this Alfred one. Okay, at the age of 30, Alfred began investing $350 into an investment account. Let's just get going here. Well, let's read it. It's more complicated, I remember now. $350 monthly into an investment account at an interest rate of 7% compounded monthly. When he turned 45, the interest rate on his investment decreased to 5% compounded monthly. He makes the same monthly investments until he retires at 58. How much money is in there? Okay, we're going to treat this as two different investments. We're going to treat this as two different accounts because this big change happens halfway through. So, age, let's see, 30 to 45. I'm going to write down my kind of variables here. Can't remember what they are. PV. Okay, so is there any money in there at the beginning? No, so present value is 0. Payment, we're doing $350 a month. $350 a month, so it's a negative 350. And that payment per year is monthly. Monthly, okay. Interest rate 7. Future value is what we're looking for. Oh, and it's compounded monthly. Periods, okay. 12 times a year, that's our monthly, times, let's see, 30 to 45, that's 15 years, right? All right, time for my calculator. Ooh, 12 times 15, what is that? 180, okay, good. Monthly, and future value. Ooh, boy, that's a lot of money. Okay, so he invested this money every month. It ended up being $110,000. Good for you, Alfred. Now, at 45 years old, he's going to take this money out of this account because it closed or whatever, like the investment changed. And unfortunately, it goes into a lower interest rate, so he won't make quite as much interest relatively, but you know, what are you going to do? So this is 45 years old to 58. Okay, so this time, this is the beginning amount. So it's a negative 110,000 because it's kind of like he took this out of this investment account and put it into a checking and then took it out of his checking and put it into a new investment account. It wasn't really his choice, I don't think, because why would you decide to have it low interest rate? You wouldn't. But some of the other stuff is the same, like negative 350 for payment, and it's still monthly. That didn't change. It still compounds monthly, I think. Yep. This time the rate is just 5. We're still looking for the future value. And periods, okay, monthly times 13 years this time. Let's figure out what that is. That's 156, okay. Sometimes it's nice to have like another little calculator off to the side here. Now this is where it becomes really important that we have our negatives properly. So we can tell our calculator properly that this time we're adding 350 every time, and so we'd say both of them are negative there. Future value is not that, but I'm just going to leave it there for a second, because that's what I want to calculate. Monthly, future value. Okay, much larger, but it grew on that 110, right? Oh my gosh. This is how much he has at the end. So he ended up with, we're not going to add them, right? Because this is already factored in, that $110,000 is already added into this investment. It's already part of this almost $300,000. Okay, let's try the next part. Now, this is a really good exercise with our negatives. We'd be really careful with them. Alfred withdraws $2,000 per month from his account after he retires, because that's how much it's going to cost him to like keep up his house and like, you know, go golfing every day, that kind of stuff. If this interest rate remains 5%, how many months can he withdraw $2,000? So he's going to keep this in the account, but instead of adding $350 every month, he's now going to withdraw $2,000. So whatever's still in there, though, he's still earning interest because you may as well, right? But now we're going to be taking money out. So let's start off with this, all our variables. Okay, how much money is in there right now? 288, and it's a negative because it's like it's coming out of our checking account. Oh my gosh. Payment. Now, I know it doesn't really seem like a payment. It's not really a payment. It's kind of like a withdrawal, I guess. He's taking money out. So we don't want to say putting money in, we want to say taking money out. So we call this a plus $2,000. Not a negative $2,000 anymore. It's a plus $2,000. Because it's going back into his checking account, right? It's coming out of this investment account and it's going back into his checking account. So his checking account is going up by $2,000 every month. I think that was monthly, so that down here is monthly. Interest rate still 5%, and I think it's still monthly. Like it's still the same investment. Future value. Now, what will his future value be if he runs this thing until it's empty? Because you're not going to stop when there's still a bunch of money in it, right? No, you're going to use up the money until it's gone. So the future value is going to be 0. At the end, there will be no money left. And the period is actually what we're looking for because that's the time, that's how many months we can go for. So let's do this here. Maybe I'll just reset because there's lots of different numbers. Payments, 2,000. Periods is what I don't know. Monthly, okay. And periods, let's see. Now that is months, which is great because that's what I wanted. So really, I'm going to say 221 because the last month he won't be able to get a full $2,000 out of it, right? Just for reference, let's see how many years that is. So divide by 12, it ends up being 18 plus years. A little bit over 18 years. That's not bad. That's pretty good. All right. We're going to skip Alfred's sister, but you tried that on your own, so we're going to skip this one. Keep going. Okay, we're going to skip it, but you try it or pause me and try it. Try it when we're done or whatever. Okay, here's a slightly new topic. It's called appreciation and depreciation. Maybe you've already heard of this. But it's talking about the value of an item and how it changes over time. Certain things increase in value and certain things generally decrease in value. For example, the sweater I'm wearing right now, every time I wear it, it's not exactly collectible, it's just a regular sweater, it depreciates in value because I'm using it, right? My regular SUV that's just in the garage there, it's a regular SUV. It's not like a collector's item. I'm nobody special. It's going to decrease in value. So we call it depreciates. If I had some kind of like collector's item, like, oh, I don't know, what do you collect? My dad likes to collect Coke stuff. So maybe he gets some like really special Coke thing, and over the years, maybe it's worth more later. We would say that it appreciates in value. So the increase in value over time. I should say in value of an asset. And an asset is just something that is worth money. Okay, so here's a formula for us. Future value equals principal 1 plus rate to the exponent t. Depreciation, the decrease in value of an asset over time. Same thing, just decrease. Very similar formula, you'll notice. 1 minus rate, the exponent time. So let's just make a note here. Future value. I think I skipped again there, but V is future value, P is principal, R is rate. This time we do need a decimal. And lastly, T is time, and that's in years. All right, so let's give this a try. Ashley buys a house in a rundown area of Winnipeg for $200,000. Finds out that the city has plans to renovate the area with new parks, roads, a Starbucks drive-thru, and doggy daycares. Each year she lives in her home, more and more people want to move to the area, and her house appreciates at a rate of 3% per year. How much is her house worth at the end of 2 years? Now, houses are a great example of something that you really just can't tell what's going to happen in the future. The last couple of years, houses in Winnipeg skyrocketed in value because of COVID. But there have been many times in the past, let's say 20 years, where houses have decreased in value. Like all the houses in Winnipeg or in Canada or something like that were just not as worth as much in general as they were like the month before or the year before, something like that. There was a giant housing market crash, especially in the States in the early 2000s. It was a huge deal, and a lot of people lost a ton of money off of it. So real estate can be a really good investment, but sometimes it has problems there too. And then it depends on your individual house, right? If I buy a house that's like a money pit, they call it, where every single thing is wrong with it and you didn't know when you bought it, you're going to sink a lot of money into it and maybe it won't be worth as much later on. You never know. Anyway, let's try this. First things first, it appreciates. So I'm going to use this formula on the left here. Future value is what I want to know. Principal, it started off being worth $220,000. 1, it's still a 1. Rate, 3%. I'm going to write that as a decimal, 0.03. And time, 2 years. Now, I do need a calculator for this. I don't believe there's one in the app, although I could be wrong. I really haven't looked into everything that's on there. Oh, there's a regular calculator. Okay, that's handy. Oh, I don't like it. Okay. I'm going to use my graphing calculator, but I suggest you use like just a regular scientific calculator. Okay, I'm going to write this all in, all as 1 here. So $220,000, open bracket. I can do that addition in my head there, 1.03, or you could say plus, that doesn't matter. Now on my calculator, it's going to look like this. It's like an up exponent. It's like a hat. Yours might look y to the x. And we're going to press that button, and that tells us that this is going to be an exponent. And then hit enter. So please try that for me and see how it goes. If you're not sure about your calculator, please let me know. Your phones are not great at this type of calculator work. So she bought it for $220, but now she could probably sell it for $233. And that's awesome because she made some money off of it. There we go. There's 2 more. Please try them. Try the homework. And that's it.